Hello everyone and welcome to another Fusion 360 Live. My name is Brad Tallis. On the keyboard is my friend Angelo Juris, who will be answering any of your questions. We're going to go through another series. You guys, I've seen some of the feedback on Facebook and in the comments that you really like these series that I go through where we assemble like a pencil sharpener or the laser projector. And so this time we're going to do this table saw stand, and you can kind of see we're going to learn a couple new things. We're going to use commands such as sheet metal to create this sheet metal part. It's got some interesting folds and stuff to it and some tabs. We're going to be doing McMaster car components, 3D splines. We're going to learn about different types of joints, so you can kind of see how this whole thing works together. We'll learn how to create the tread on this tire, etc., etc. So I'm also going to be showing some new functionality. In fact, I included the outline and the drawing set in the description of this video, but I actually updated it today because of new functionality that we just released yesterday that we're going to incorporate in this design. So you'll see that as we go through. So with that, let's dive right in. Like I mentioned before, the outline and the drawing set are in the description of this video, so you can download those at a later time if you want to. Okay, so the first thing we're going to do, actually I'm going to point out some of the new functionality that I was talking about. This is the drawing set, and this is what we're going to be working on today, is this this exploded view assembly that you see. I'm going to jump over to the tube, and here is one of our new enhancements. You'll notice that we just added in broken views into the drawing. So even though this pipe is much longer, I was able to create a broken view. You'll notice that the dimension is correct and even shows a little broken view icon in the dimension, which I think is really kind of slick. So we're going to start out by creating these parts that you see on the screen here. I'm going to show some cool tips and tricks on modifying multiple parts at the same time. So we're going to learn that also. We're also going to learn about thin wall extruding. We just added that, and we're going to use that in this example here. So here's just the drawings we're going to be using, and then on this piece here it actually goes between the two pipes, and you'll see it actually conforms to the pipes. On this drawing you'll see that it says length defined by the spacing between the tubes, so we're going to learn how to do that also. Okay, so the first thing I want to do is, in this design we're going to be using metric. So I'm going to change my unit type to millimeters. I'll say okay, and hopefully that makes a bunch of you happy. I know we try and switch between inch and metric to appease everybody. So I'm going to start by creating that tube, and like I've mentioned before, we always want to start with a component. So I'm going to right click at my top level and say new component, and we'll give this a name. I'm just going to call it tube, and I'll say okay. And you'll notice I now have a new component called tube. The other thing I'm going to do, I'm going to go ahead and save my design right now. You'll notice it says untitled. I'm going to go ahead and save this. I'll call it live stream stand. That way, like, my auto save starts to kick in automatically. So it's always a good idea to save your design right after you start. Okay, so let's check out one of these new commands. So I'm going to create a sketch on the side plane because the pipes are going to kind of be going left to right. So I'm just going to create a sketch on the side plane here, and I'm going to draw a circle. And in this case, I want it to be 45 millimeters in diameter, so I'm going to type in 45 and hit enter. Okay, in previous releases, if I wanted to make this a pipe, I would come in here and say extrude, and then I'd have to shell it out, and I'd have to select the front face and the back face to do the shell, and then I'd type in the thickness, and so it added a bunch of extra steps into my timeline. But you'll notice in the extrude command we now have this new option called thin extrude. I'm going to go ahead and select that, and you can instantly see what it does. It allows us to add in a wall thickness. So let's do something like 3 or 6 or something like that. And you can see it's going to take the profile and basically add a wall to it. So really cool command called thin extrude. We're going to use that a couple times today. So I want my wall thickness to be 1.5, and my total length, according to the drawing, was 1200 millimeters. I'll go ahead and say OK. And you'll notice I have just one feature in my timeline, the extrude feature, but we have a hollow, thin-walled pipe. Okay, I'm going to jump back to the drawing here real quick. Let's jump back here. I'm going to create, you can see that we're basically going to be creating the pipe, and there's a little nut that's actually welded to the top of this pipe. And we're going to, when we create the drawing set, we're going to learn how we can add welding symbols and all that kind of stuff to our drawings, because we now have welding symbols. But to do that, I'm going to put a hole through the part, and then we're going to insert in one of these metric 8 hex nuts. So I like to use the hole command. So let's kind of zoom up here. I'm going to say the hole command. I'm just going to click somewhere kind of near the top. And what's kind of cool, in fact, I'll kind of go to a little bit of an angle over here, and by default, Fusion is going to put that on the very top of the part. Okay, if I had clicked more toward the side over here, it would actually put it on the side every 90 degrees, which is kind of cool. Okay, and I'm going to make this a little bit larger so we can kind of see what's going on here real quick. So you can see that there is the hole. I want it to be a certain distance from this edge here, so I'm going to just click on that face, and you can see it allows me to enter in a distance. In this case, it's going to be 30 millimeters from that face, and you can see when I type in 30, it goes ahead and positions that hole, the center of that hole, to be 30 millimeters from that edge. Okay, the other thing is, let's say by default it came in looking kind of like this, where it's going all the way through the part. And when I say by default, it usually remembers the last screw type that you did and the last length and the diameter, etc. So sometimes it goes all the way through. Well, I only want it to go through the top of this pipe. So I'm going to change this distance, and I'm going to say 2. And I'm just going to click on the inside of this pipe, and now you can see that it's only going to cut through the top of the pipe. I can tell it I want a simple hole. I want it to have a flat drill point. In fact, it really doesn't matter in this case, but I'm going to leave it flat. And then finally I'll come in and specify the diameter, which is 8 millimeters in this case. And I'll say OK. And we just created a hole. Now, why did I use the hole command to do this? Well, one, you can see it creates a feature in my timeline. But think about how would I have to have done this with a sketch. I might have had to come in here and say, we want to create a tangent plane on that face. You can kind of see it does that. Then I'd have to create a sketch on that plane, etc., etc. Draw the circle, dimension it from the edge, which would totally work. There's nothing wrong with that. But I find this just to be much quicker, and it's really easy to come back and edit that feature. I could come in and change the size of the hole. I can add it to have a countersink or whatever to it, for example. So I really like the hole command. Okay, now let's go ahead and put that nut on top of there. So I'm going to insert a McMaster car component. I'm going to make the window a little bit bigger so you can kind of see what's going on here. In the outline, I not only describe, in fact, I'll show you, it'll ruin my thing here, but on the very first page, you'll see I even call out what it is, and then you'll also notice a part number. This is the McMaster car part number, so you can search for them, or you can actually search for it using this information here. So I'll do a little bit of both so you can see how that works. So I'm going to do the McMaster car again, make this a little bit larger. So for example, I can click on the nut icon, and then over here I obviously want a metric nut, so I'm going to click on metric, and it kind of filters some things out. I also know that I want a metric 8, so I'm going to go ahead and click on the M8, and then you can kind of see it gives me different options of all the different types of nuts. Well, I want to do a hex nut, like so. And then it displays all of the different kinds, whether it's medium strength, you know, is it fine thread, regular thread, etc. And in this case, I'm going to go ahead and just do this first one here. And so this is that part number that I was telling you about. So I'm just going to click on that. And if you see this little CAD symbol, that means that there is a 3D model associated with that. So I'm going to click on Product Detail. And you'll notice right here where it says CAD, I can come in and say I want, you know, a SolidWorks file, an IGES file, a step file. I can even say step with no threads, which is kind of cool. They just added this functionality. And then even 2D drawings if I wanted a 2D drawing. I like to use the step format, and I'm going to say download. Now what this is going to do is you can see it very quickly brought it in, but it's kind of in the wrong spot. So I'm going to drag it sort of close to where it needs to be. Okay, not exactly where, but pretty close, something like this. And then you'll notice in our move we have this capture position. This is a free position. So typically when you say capture position, it captures it in your timeline. And so that could make your timeline get fairly complicated pretty quickly. But with this inside here, when I say OK, you'll notice it didn't add that feature into the timeline. So it's almost like a free capture. Okay, now I want to put it where it needs to go. And to do that, we're going to use the joint command. So I'm going to say joint command. And like I've mentioned in previous live streams, I always usually get questions like, well, does it matter which order you click? And the answer is yes. And so you can see here it says component 1 and component 2. And I came up with a little phrase that helps you remember which one do you want to move and where do you want to move it to? Well, this is the one that I want to move, and I want to move it to the pipe over here. So I know that component 1 is the one I want to select first. And you'll notice when I hover over this face, in fact, let me kind of move a little bit, I get all these little tick marks where I could select. Well, I want to grab the center point, okay? Now, as I'm moving around, you'll see it kind of flashes quite a bit, and it's kind of hard to catch that point because it's looking at other edges and faces and all that kind of stuff. So I want to control my selection. So on a PC, I'm going to hold down my control key. And now notice as I'm moving around, it's not selecting any other edges or any other faces. I'm actually controlling my selection. As soon as I let go of my control key, it starts flashing again and all that kind of stuff. So a neat little tip, hold down your control key, and that allows me to basically say I only want to capture the tick marks that are on the face that's kind of selected right now. So I'm going to grab that middle point right there. Okay, where do I want to move it to? Well, this is interesting. This is a curved surface. And you'll notice if I hover over this edge, the joint origin isn't really giving me anything that's really helpful. And the nut will be positioned in the wrong position. But watch what happens when I hover over the whole face. So you can see this is the face that kind of defines the whole. And you'll notice it has a top, a middle, and a bottom. So I'm going to click on that top mark, and you'll see that sure enough, it moves the nut, and it lines up those 2 points, just like you were to set that nut on top of a curved pipe. Now, if I could show my, well, I can't really move my camera or whatever like that, but you'll actually see there's the stand in the background. That's what I've been modeling it off of and all that kind of stuff. There's a weld. They just basically put the nut there and they kind of weld it around that. And we're gonna do that when we get to the drawing set. But so I'm going to go ahead and say OK, and we've now positioned that nut on the end of that pipe. And if I were to move the pipe, you can see that the nut moves with it. Okay. Moving forward here, there's also basically what this nut is for is there's a knob that goes into here, and it helps hold the extension arm in place. So let's go ahead and insert in another component, McMaster car component. And instead of clicking through and looking for it this way, you'll notice that there's a find search window right there. So I'm going to do a search for the part number, which in this case was 2907T27. And when I hit enter, you're going to see that it's actually going to find the 7-arm grip, black nylon plastic or whatever. You can kind of see here it found, let me move this over a little bit. It found that part number, okay? So I didn't have to go searching for it, but you can see, sure enough, it's a metric 8, all that kind of stuff. So I'm going to say product detail, that's what it looks like. I want the step file, I'll say download. And just like before, it's going to insert it into our design. And you'll notice it kind of came in at, if I turn on my origin, you can kind of see those light orange planes. It basically comes in at 0, 0, 0. But we're working at the other end of the pipe. So I'm just going to drag this over. Kind of drag it up a little bit, get that free capture position, and then again I'll use the joint command, which is the one that I want to move, this guy, and I'm just going to catch the center bottom right there, so I'll click there. Where do I want to move it to? Well, I want to move it to this, and I'm going to look inside the pipe. And again, I'm hovering over the hole, and you can see that it has a top, a middle, and a bottom. So this time I'm going to click on that bottom point, and you can see how it brought the whole knob, and the bottom of the thread is basically right there at the bottom of that hole. Kind of a cool little trick. In this case, I'm leaving these as rigid. I mean, I could make it revolute and all that kind of stuff, but in reality, there's no need to. I want these to move together, so I'm going to make it a rigid joint type. And I'll just say OK. And if we move the pipe, sure enough, the nut and the knob move together. Just for fun, I want to change the color of the knob, because on the real one, it's yellow. So I can come under here and go to Modify Appearance, or the A key for the shortcut. So I'm going to hit A, and you can tell I was already in there. Here's all the different default materials. So I'm going to go to Plastic. You can see we have different plastics. I'm going to go to Translucent, and there's a glossy yellow. So I'm just going to drag and drop that onto the knob. Okay, now unfortunately, because this is a McMaster car component, you'll notice it's one part. In fact, let me open the tube here, and you can see, because this is our active component, these parts came in underneath that component. Here's the body, and you'll notice it's one solid body, which isn't very realistic for rendering or anything like that. So here's another little tip for you. I'm going to switch back out of plastic. Let's go into metal. Let's just go into like steel. Now you'll notice it says bodies, okay? Well, if I were to drag steel onto here, it'd make the whole thing steel. Well, I'm going to change this to faces. And now I'm going to zoom up here. I can drag this steel rough onto like that thread, and you can see that it just colored that face. So I'm just going to do that again. I'll do that with this face here, and then finally the inside thread. And so I just colored those threads, the individual faces, a different material. So kind of a neat way to colorize certain things. on your part. So for example, this whole thing could be yellow, but maybe this top part I wanted it to be black or something like that. I could just assign it to that face. Okay, so I now have a tube, and if we jump back to this assembly here, you can kind of see we basically created this tube, and it's the exact same thing over here. So we're going to learn how to, move and copy and all that kind of stuff. So what I want to do is start to kind of organize. So here's my tube, and I'm going to basically create an assembly. So I'll right click up here and say new component. Now the reason I like to right click here and do it instead of from the menu is I'm basically telling it where I want that component to be. So for example, if I right clicked here and said new component, it's going to put it underneath the tube. Okay, let me undo that. But if I were to say here and say new component, it's going to put it underneath the stand. So let's call this table assembly. I'll say OK, and now you can see I have this table assembly component. Well, I want the tube to be part of that, so I'm just going to grab the tube, I'm clicking and dragging, I'm going to drop it onto the table assembly. And now you can see, if I expand this open, that the tube and everything that has to do with the tube, such as the nut and the handle, are underneath this table assembly. Now what I can do is right click on tube, and I'm going to say copy. Now there's a couple different ways of doing this. You'll notice it says move copy, and this would give me the exact same result. Okay. However, I'm going to show you there's two different ways of doing this. So I'm going to say copy. Okay. Then I'm going to right mouse click on table assembly, and now you can see paste and paste new. We're going to talk about paste new in an upcoming live stream. In this case, I'm going to just say paste. Okay. Notice my browser. I now see a second tube. I'm also in my move command, and I basically want to kind of move this off to the side, and I want to rotate it 180 degrees. Now, how far do I need to move it? I have no idea. I'm just kind of moving it off to the side. We're going to let the 3D model define the spacing of these tubes. I'll just go ahead and say OK. And now you see we've got this tube assembly here and this tube assembly there. Really quick way instead of having to recreate geometry. Okay. Let me zoom out a little bit here. Let's take a look. So we created the tube. We did the hole 30 millimeters from the edge. We put the steel hex nut on top of there. When we did the extrude, we specified it to be 1.5 millimeter wall thickness. So we're basically done with this guy. So let's move on to this part here, which is what we're calling the end cap. Pretty simple part. Okay. And I'm going to be using these dimensions to help me define the shape. So once again, I want to create a component. Now, why do I always create things as components? Well, it's going to keep my timeline much easier to manage. So I'm going to say new component. We'll call it end cap. I'll say OK. Notice my other parts kind of ghost out a little bit, and my timeline has nothing in it so far. And our end cap is our active component. Okay, so I'm going to create a sketch. And again, I know it's going to kind of go across this way, so I'm going to put it on this plane here. But just to be different, I'm going to draw it out in space. I'm not going to put it right where it belongs. I'm going to kind of do it out in space, and then we're going to move it into place. And the overall shape kind of looks like a slot. So I'm going to use the center to center slot command. And again, I'm just going to randomly pick somewhere in space. The overall length is 185. So I'm going to type in 185 from center to center. It's at 0 degrees, so I'm going to hit enter there. And now it's asking for a diameter. And it's a 48 millimeter diameter. I'll hit enter, and we can see what it did. It created this slot feature. So instead of having to do 2 circles, some tangent lines, trim them, dimension them, etc., I just used basically 2 mouse clicks with the slot command. Okay. Like I've shown before, I'm still in my sketch, but I can click on my profile, right mouse click, and say extrude. And it's going to finish my sketch for me, and it's going to put me into my extrude command automatically. The overall depth is 19, so I'm going to say 19, and we'll say OK. And now you can see in my timeline, there's the sketch, there's the extrude, the body for it, the sketch for it. It's all organized inside that component. Okay, let's shell this part out. Now, I'm going to use the shell command. So I'm going to select this face and say shell. And it is a wall thickness of 1.5 according to the drawing. And there we go. We basically have this cap. Now you might say, well, how come you didn't do the thin wall extrude? Well, the thin wall extrude is kind of like for a pipe, right? It didn't seal one end and leave the other end open. Shell allows me to say, I want this face open and everything else stays closed. And so you can kind of see, sure enough, that back face stayed closed. If I had said, do a thin wall extrusion of 1.5, I say, okay, this is the result I would have got, right? And I wanted to keep that back face. So that's why I didn't use it in this case, okay? Oops, let me change it back to this guy, say okay, there we go. Okay, now, according to the drawing, there's some holes, there's a rectangle that goes through and all that kind of stuff. We're actually going to come back to that later. I'm going to show you how we're going to use some cool tricks to modify multiple parts at the same time. So I'm actually pretty much done with this part. I'm going to start working on this part, which is the end cap cover. It's a plastic cover. This guy is made out of metal. This one's made out of like plastic, and it helps kind of protect it. So we're going to, again, use information from this drawing, and we're going to use information from the other model. So let's jump back into here. So under the table assembly, I'm going to create a new component. I'm going to call it end cap cover. You'll see that kind of ghosts out a little bit. Now what I want to do is I want to create a cover that's basically just going to slip over the top of this. And I could go back to my drawing and, or take measurements and all that kind of stuff. But here's a neat little trick to do what I would call kind of like an overmold. I'm going to switch to the surface tab. Now we're in thin wall surfacing. So we're no longer in the solid tab, we're in this surface tab, and I'm going to create an offset. So it allows me to create a new surface at a specific distance from the selected face. So I'm going to say offset. What are the faces? So I'm going to click on that guy there, and you'll notice by default it chains all the way around. And I'm going to over exaggerate just so you can kind of see what's happening here. So it's taking those surfaces and it's going to offset them and create a thin wall surface. Now I also want to grab this face here, so I'm going to control select that face there, and you can see what it's doing. It's taking those faces and just basically creating a thin wall offset. Well, I don't want it to be 5 millimeters. I want it to be 0.5 millimeters. I want it to just barely clear this other part. So you can kind of see the distance there. Also watch what happens under my bodies folder when I say OK. You'll notice that the icon looks different than a solid body. This is a solid body here. This is a surface body. In fact, if I turn off the end cap, we can now see it's just this little thin, no thickness part. However, under the Create menu, you'll notice there's a command here called Thicken. So I'm going to click on Thicken. It's asking for the faces. And you can see by default what it's doing. Again, I'll over-exaggerate. Now, it only grabbed that loop, so I want to make sure I add in this face here also. And it's now almost like we're taking that surface and giving it some thickness. And in this case, it's supposed to be 3 millimeters. I'll say OK. And you'll notice I now have a body. I still have this thin wall body. It got turned off. It's still there. I can reference it. I could use it or whatever. But I now have a solid body that fits perfectly over this other part with 0.5 millimeters of clearance. Now that's a different kind of a method, right? I could have recreated. I could have created the slot, the correct dimensions. I could have extruded it, shelled it out, made sure it had 3 millimeters of wall thickness. Totally would have worked. But this is kind of a neat trick to kind of do like an overmold. Like I want something to go over an existing shape that I have at a certain thickness and have it follow those surfaces. So that's why I showed this particular method. Hopefully that makes sense for all of you. Okay, so now what we're going to do is, if I look at the assembly here, you'll notice there's some screws and some bolts or some nuts attached to those, and they go through both of these parts. And this is what I was going to show you. That's why I created both of these parts first, and now we're going to position the holes for those screws. So I'm going to still make sure I'm on my end cap cover. That's my active component. I'm going to go ahead and create a sketch on here. And I want these screws to be located at very specific points. So I'm going to, under the Create menu, say Point. And I'm just going to go ahead and drop these points somewhere. I'll put one there, maybe one over here, and one down here somewhere. Okay, so I just created 3 points in space on that face. Now I can use Fusion to kind of define exactly where I want these to be. So, for example, I could say I want this point to be horizontal with the center of this arc here. So you'll see it dropped that down. And I want this point to be a very specific distance from the center of that arc. In this case, 30 millimeters. And you'll see it kind of jump to the left a little bit. Okay. Same thing with these guys. I'm going to constrain those. I want those 2 points to be vertical with each other. I also want them to be a specific distance apart. I want those to be 25 millimeters. Okay. Now if I move one, the other one has to move with it or whatever. I can also specify that I want that to be a certain distance from the arc, the center of the arc, so I'll say 30. Now if I grab on these guys, you can see I can still move them up or down. Okay, so neat little trick here. I'm going to create a line, and here is something new that we just added yesterday. You'll notice in my sketch palette, we've always had construction geometry. We also now have center line geometry, and this is actually really cool. If I draw a center line and then I click on revolve, it automatically knows that it's going to revolve around that center line. So you'll see some new functionality with this in upcoming live streams. But I'm going to go ahead and do just a construction line between these two. Okay, and then I'm going to do a line from here And then I'm just going to hover over this line, and let's zoom up a little bit, and keep moving down until you'll see it's going to snap to the center point. So it kind of sees that little triangle appear, so I'm going to go ahead and click there. Now I have this line that I can say, I want that line to be horizontal, and watch what happens to those points. It has to move those down to keep that point at the center of that. So now I know that these 2 points are centered where they need to be. And we can see that it's fully constrained. And that's it. I'm not going to draw any circles or anything like that. I'm just going to say finish sketch, but I now have these points where I want them to be. We're going to use the hole command. So I want to make sure, you'll notice I'm in this surface tab still. I'm going to make sure I go back to my solid tab. And then I can see the hole command. In fact, I don't even think there is a hole command in the surface tab. So we're going to go to the solid tab. I'll say hole. And right here under placement, it says at point for a single hole, or from sketch, multiple holes. And we basically created a sketch. So I'm going to click on that guy. What's my sketch point? I'm going to click here. And let's just zoom up so we can kind of see what's going on. I'm going to go ahead and drag like so. So we're extending past. Now here's the magic. Notice right here it says objects to cut. And it's folded up. If I click on that and I expand it, you can see that it's going to cut through the end cap cover and the end cap at the same time. And I can visually see that. If I kind of look in there, you can see there's the end cap and this is the end cap cover. I could say I don't want it to go through the end cap, even though it physically is. So you have the ability to turn those on or off. But what's cool about this is we're basically putting the holes through 2 parts at the same time. Okay, so instead of distance, I'm going to say go through all. It's going to figure out how far it needs to do that. Also, I want to have a chamfered edge, so I'm going to say countersink. And it actually remembered my last entry. So it's 11.2. Let's pretend that wasn't the case. Let's just do like 6 or something. Okay. So I can come in and say I want it to be 11.2, and you'll see that it will create that chamfer for me. And then what's cool is I need to make sure my diameter is correct. So in this case, I want it to be I don't even see it. I apologize, guys. Let me look at the drawing. Okay, diameter is 6. And then this little symbol you see right here, this is that countersink symbol. So there's that 11.2 that I was talking about. So we're going to do a 6mm hole. So I apologize, I didn't have that in my outline. Okay, so this needs to be 6. And then I can just click on other points. I'm just going to click, and it's going to use all that information and position those at those very specific points, and we can see that it's going through both parts. And this is exactly why I said on this drawing here, even though there's dimensions and holes, we're going to leave that alone. We're going to have this model define where the holes are. You know, it has the countersinks and everything like that. Okay, so continuing on with this design, there is this little plastic extrusion. We can see it comes out 25mm. It's 35mm square with a 2mm wall thickness. So I'm on this end cap cover. I'll go ahead and edit this sketch again. Instead of having to create another sketch, I'm just going to go ahead and edit this sketch again. Rectangle, center, rectangle. It's at this point right here, and it was 35 by 35. I'll click on that profile and say extrude. Okay. Now I'm going to start to drag so we can kind of see what that looks like. And we know we need to go 25 millimeters for the total extrusion. But once again, here is where this thin extrude really is going to come in handy, because it's only going to affect this part right here. If I said okay and had to do a shell, the shell is going to incorporate all these other faces. So I'm going to say thin extrude, and let's change that wall thickness to 2 according to the drawing. I'll say okay. Now you're going to see a little bit of an issue. It doesn't go all the way through the part. Well, that's okay. So what we're going to do now is make sure my end cap is turned on. I'm going to turn off my sketch so it kind of keeps things clear. And I'm going to click on this face and say extrude. Now watch what happens. If I go this way, it's going to add material. If I go this way, it's going to start to cut material. And just like before, notice it says objects to cut. If I were to change my distance to all, notice what it's going to do. It's going to take this shape and it's going to cut through both our parts. I'll say okay. We can now see through, and it's cutting through our end cap. Now, why does this matter? Well, check this out. I'm going to go back to this extrude here. Let's change the wall thickness. Let's make it something like 6. I'll say okay, and our hole updates accordingly. So no matter what this wall thickness is, it's going to stay the correct size going through. Let me go ahead and undo so you can see that. Sure enough, that updates also. Kind of a cool little trick there with that cut command, objects to cut. We're doing one thing and it's affecting multiple models. And they're kind of linked together, right? If I change something on one, the other thing has to update accordingly. And this is where I really kind of geek out. Check this out. I'm going to activate my end cap. And notice there's the extrude right there. It automatically added it to my end of my timeline of that component. Automatically. The last thing we did, and notice it even did the holes. The last thing we basically did a sketch, we did an extrude, and we did a shell, and that's where we stopped with this part. But because we cut into them with the hole command, and because we cut into it with the extrude command, it added those into the timeline. Pretty powerful, I think. Okay, let's finish this guy up. According to the drawing, there's a 1 millimeter radius that goes all the way around, and we want to change it to be a different material. So I'm going to select that edge, say fillet, 1 millimeter. So I'll say okay. So I see somebody asked a question, is there a way to change the name of the instance? I guess I need a little bit more clarification. Are you talking about, like, for example, this is called end cap cover, and then there's just a body. I can rename this body. I could call it, my cover or something like that. It really doesn't matter in this case. Okay, so you can change the names there. If in here, I could also change the names of this extrude. So if I right click, you can see it says rename. So I could call this, hole through, both parts or whatever. You can give those things names. So notice this says fillet 1, but if I hover over this, it now says hole through both parts. So, okay. So let's continue on here. I want to change the appearance. So I'm going to hit A for appearance. We're going to make this out of plastic. So I'm going to go to plastic. You can see some default plastics here. I want to do a textured plastic. And you can see here, plastic texture random, polka dot regular, skin. We have a couple different ones. I'm going to just do this random. I'm just going to drag and drop it onto my part. And if I zoom up here, you can kind of see what that looks like. I can edit that. I could change the color to be a, more of a red or whatever, or a lighter gray. You can kind of come in and change that all you want. So I'm just going to go ahead and leave it like so. And it's a little bit of a lighter gray in this case. Okay. Okay, so looks like Angelo clarified the question. So where here it says like tube :1 and tube :2, that the instance number. So in this case, I can't change, I can't rename, to be 001 or 002 or anything like that. So those get created automatically. So a great question, whoever asked that. Okay. So we now have the end cap. We have the end cap cover. What we want to do now is kind of assemble these together. So I want to make sure that the table assembly is my active component, because I'm going to start adding some more stuff into it. So I'm going to go to table assembly. That's my active component. And then I'm going to insert a McMaster car component. So we'll come here, make that a little bit larger. And in this case, I want to do a metric 6 Phillips flathead screw. So I'm going to go to screws and bolts, metric. I'll filter for metric 6 only. And then if I kind of scroll down here, you can see all the different types. Well, I want to do a flathead screw, and 14 millimeters long. So that's this guy here. And so you can kind of see it's basically filtering everything out to show the different types of 14 millimeter long metric screws. Well, now the only thing that's left are the different head types. So you can see this is a hex drive, then we've got Phillips, etc. And you can see right here, I'm going to switch to Phillips. And now it's only showing me the Phillips heads. And this is the one that I want. Or I could have just searched for that number up here. But I like to kind of show the power of this filtering over on the left. So I'm going to grab that guy. We'll download this. And again, notice where it kind of came in. So I'm going to get it sort of close to where it needs to be. It doesn't have to be exact or anything like that. I'm just going to put it like there. Capture the position. I'll say OK. We'll zoom up. And I'm going to create a joint. So what's the one? Well, I'm going to line up the top edge. Since this is kind of like a tapered edge or whatever, I'm just going to grab that edge there and this edge here. Now you'll notice it put it in the right spot, but obviously facing the wrong direction. Well, I can say flip, and it's going to flip that around. And we can see that sure enough, that's going through the part. I'll say OK. We've just positioned that. And again, I'm doing these as rigid instead of revolute or anything like that. Now I want to create a nut on there to kind of hold this whole thing together. So just like before, we'll do a metric 6 in this case. So metric 6, hex nut. You can see we could do lock nuts, etc. So I'm going to say hex nut. And I think in this case, it's this 016. 3D step. I mean, a lot of this is repetitive, so I'm kind of going a little bit faster. Bring that up, bring it over, capture the position, say OK. Now you'll notice, because my table assembly is active, here's that rigid joint right there. So it's showing up at the table assembly level, not at the very top level. These joints are basically have to do with this table assembly. So that's why I made that active, and these are the joints that are going to be underneath that assembly. In fact, watch what happens to rigid 1. When I create another one, you'll see another rigid appear. So I'm going to say this face here to this center point there, and it puts the nut in the correct location. I'll say OK, and now we can see that second rigid joint right there. Okay, so what happens if I move this black part now? I'm trying to highlight things that happen to me all the time. I'm going to go ahead and move this black part and you'll notice that the screw moved, but the nut did not. Okay? Why is that? And this part didn't move. Well, I didn't build a joint between this metal part and this plastic part. Okay, so that's why they didn't move together. And when I positioned this nut, I actually captured the whole location on this part, not on the screw, so the nut is associated with this part here. I know this can get a little bit confusing, and so here's some tips that I use that kind of help me out. These are basically assembled the way that I want them to be. So under the Assemble menu, there is a command called rigid group. I'm going to say rigid group. What are the components? Well, I'm just going to say yes. And I'm going to select that guy also. And I'm basically saying make all of these rigid with each other. So I'm going to say OK. And now when I grab that black part, they all move together. It doesn't matter which part I grab, they're rigid, they're glued together, welded together, whatever term you want to use, it's a rigid group. Okay? So remember when we created this black part, we basically just grabbed the surfaces of the gray part and we thickened it and stuff like that, but we never ever said, you know, create a joint between the two, and that's why they were separate. Hopefully this is making sense. I'm trying to show you my struggles that I run into sometimes as I'm going through these designs. Okay, I want to have these guys be over here also. Oops. So I'm going to select both of these, right mouse click, and say copy. Now I want them to be underneath my table assembly, so I'm going to right mouse click on my table assembly and say paste. Now why am I emphasizing this? Well, I could right click on my, I can make this active. I could right click here and say paste, right? And then it would put the screws up underneath the whole stand. I want them to be underneath this table assembly. So I'm going to right click here and say paste. And by default, it puts them in the exact same location. So I'm going to just drag these to the left out here in space somewhere. And I'm going to say OK. Now, here's where things can get a little bit interesting. I copied the screw and the nut, but watch what happens when I grab the screw. The nut does not move with it. Why is that? Well, it did not copy the joints because I said copy this guy and this guy. Notice the joints are up here, right? The joints aren't underneath this assembly here. In fact, these aren't even assemblies. These are just plain old components. So sometimes you'll like copy something and then you'll go to, you know, change it and you're like, why didn't that move together? And that's because the joints are actually right here. Now there's a simple fix. I'm just going to come in here and say I want those to be together, so I'm going to say rigid group, that guy and that guy. Now they move together. I'll go ahead and create a joint. I'll say that edge there, that edge there. Now don't freak out. You'll notice the nut didn't move, but as soon as I say OK, it has to update that rigid joint. So sure enough, that worked. Let's do that again. I'll copy. And this time, instead of copy and paste, I'm going to use this move copy just to show you it's the exact same thing. So I'm going to say move copy. However, you have to be very aware. The very, very first thing you need to do is hit this create copy. Because if you start to drag, you'll notice it's not doing that, okay? So let me go ahead and select these again real quick. I'll say move copy. I want to create a copy of the nut and the bolt. And I'm going to drag that to the left. And you can see now it's creating a copy. It's allowing me to move those. But just like before, there's no it didn't copy that joint. So I'm going to do this rigid group one more time here. Say OK. Add the joint from here to here. Say OK. And we now have this, what I would call an assembly. Okay, and if I move any of them, they all move together. Okay, now you'll notice my structure is getting a little bit crowded. So I want to kind of clean things up. And basically what I mean by that is all of these little nuts and bolts that, you know, because we've made copies of those, they're kind of being listed here. So I'm going to create a new component at my table assembly. I'm just going to call it hardware. I'll say OK. And now you can see I have a component called hardware. I'm going to go ahead and grab those guys, drag it inside there, and now notice how simple that looks. Okay. I'll come back to my table assembly. I'm going to go ahead and move and watch what happens. Okay. Again, I'm not the best person to explain why did this happen. My understanding is because of how I reorganized this. It's actually tied to the timeline, when things happened in time. And by reorganizing, by moving those into the hardware, it forgot, or it hasn't even happened in time yet, that those were supposed to stay stuck to the screws. Okay? And like I said, I'm showing you my mistakes. I'm showing you what I struggled through, because I hear this a lot where, you know, you'll mirror something and there's a part out in space somewhere or whatever. So I'm just showing you some tips and tricks on what I do to get through some of this. I do know that, you know, the people in charge of Fusion are trying to come up with, you know, better methods that might make this easier in the future, make more sense, like why is things happening the way they are. But if you really dug deep into this, it makes sense what it's doing. All has to do with the timeline. Now, I don't want to get too deep into that, so how would I fix this? Well, just like I did before, I could come in here and say, you know what, Fusion, I want this to be a rigid group. So I'm going to say rigid group, and I can select yes. So I'm going to say yes on those guys. Hardware, and notice actually in the timeline, you can really see what's kind of going on. It's selecting all of those components. So I'm saying I want these guys to stay together. I'll say OK, and there we go. So yes, it's creating another rigid joint in this case, but it's not really affecting anything. Like, I mean, it's adding an extra thing into my timeline, but this is my method. Now, if you guys have other methods that you have found that works really, really well for you, put them in the comments in the YouTube video so we can share that with other people. Like I said, I'm not a pro when it comes to assemblies and copying and pasting and all that kind of stuff. You're going to learn about paste new. You'll hear my struggle with you know, wanting to copy and paste and something happens. So I learned about why we would use paste new. So you'll see that in an upcoming live stream. So, okay. At the top of the hour. So we are pretty close to being done here. So I want to position this into place. So let's create a joint. And which component do I want to move? Well, it's basically this gray part. And I want the center there to be at the center of this tube. So I'm just going to hover over the edge of that tube, kind of move so you can kind of see what's going on here. And you're going to see it's going to move that component over. And as soon as I say OK, everything else moves over also. Okay, I know that freaks a lot of people out when they say joint, they click on that and they click on that and they only see one thing move. The answer to it is right here. Which component are you moving, the end cap, and where are you moving that component to, the tube. It's not asking you which components and listing all of them. It's basically 2 components. And as soon as you say OK, all of the other, rigid joints, revolute joints, etc. are updating accordingly. Okay, so now we have that in place. Now I know where to put this tube. So again, I'm going to say joint. Now I want to move this guy to here. So which component, which one do you want to move? I'm going to just grab the edge there. Where do I want to move it to? Well, check this out. I'm going to zoom up here, and even though there's a hole that's kind of going through it, I can still select that center point. And it's going to bring that tube over. You can see how good that looks. That's floating out in space, but as soon as I say OK, obviously that has to update accordingly. Okay, so we now have the tubes located where they need to be. So the next thing I want to do is basically create a copy of the this whole end cap going on, okay? So it's a cap, it's a cover, it's got some hardware. I could probably organize that even a little bit better. So let's right click on table assembly, new component, and I'm gonna call this end cap assembly. There it is. I'm going to select these 3 and just drag and drop it onto end cap assembly. I expand that open. Now I can see all the parts that are in there. But instead of having to select multiple things each time, I can now say, for example, I want to move copy the end cap assembly, and it's going to grab everything inside of it. I'm going to say create a copy. Oh, okay, and here's something good. I run into this a lot too. The selection cannot be copied because it contains the active component. So to copy the selected components, first activate the component you wish it to be copied into. So basically what it's saying is you can't copy the active component. So I'm going to make my table assembly active. Now I'm going to come in here and say move copy. Create copy. Now it's happy. I'll drag this guy. I'll rotate it 180 degrees, making sure it's 180. And I'll say OK. And notice I now have 2 end cap assemblies. That one there and that one there. And I should only have to do 1 joint for this guy. So I'll say that point there, that point there. It moves the one part. We can see where it's supposed to be. I'll say OK. And it did not move all of the rest with it. Why is that? Well, it didn't copy any of the rigid joints or anything like that with it. So again, really quick, simple solution. Rigid group. I want the end cap assembly all to be rigid with each other. I'll say OK. We'll create that joint again real quick from there to there. I'll say OK, and everything moves together. All the screws, the nuts, everything. So that rigid group command is actually really, really powerful. I use it quite a bit. Okay. I know we're going through at a pretty good pace. Running a little bit long, but that's okay. The last thing I want to show is this little center tube. It's only 25.4 millimeters in diameter, so it's a little bit smaller than the other tubes. And I want it to be exactly centered. Now, if I turn on my origin, you'll notice it's off to the side somewhere. I didn't create things symmetrically or anything like that. So I've kind of dug myself a little bit of a hole. But in reality, this happens all the time. I didn't realize I should have made it symmetric or anything like that. So how can I get something that's exactly centered? Well, we're going to use construction planes. I'm going to show 2 different methods. One is a little bit longer and I think will make more sense. And then the other one's faster and you'll be like, oh yeah, I'll probably use that one from now on. So what we need to do is we want to create a mid-plane. Now, it allows you to create a plane between two faces or work planes. Well, unfortunately, if I come in here and say mid-plane between this pipe, you'll notice it does not let me select that pipe because it's not a planar face. Okay, so what we need to do is to create some planes. I'm going to turn off the two end cap assemblies, and there is a cool command in here called plane at an angle, and this is going to allow me to create a plane through an edge or an axis. Notice the pop-up next to it, or a line at a specific angle. So I need to, because these are round, I need to create an axis first. So I'm going to go to construct, axis through cylinder. What's the face? I could do the inside face or the outside face. It really doesn't matter. And you'll notice that it's putting an axis right through the center of that cylinder. I'll do that again. I'll repeat my last command. I'll put an axis through this guy. So now I have an axis. I can say plane at an angle. What's the line? And now notice it's letting me click on that line, where before it wasn't letting me do the face. I can click on this line and you can see that it's going to put a plane on that line. Well, I want it to be vertical, so I'm going to just rotate this guy, and that plane is now rotating around that axis to be 90 degrees. Right there. I can shrink these down. I don't know if you guys know this or not. If you get near the corner, you'll see the little dot appear. I can do that on any corner of a plane. So there it's a little bit nicer. So I'm going to do that again. Plane at an angle. On this edge, rotate it 90 degrees. Making sure it says 90. Sure enough it does. I'll shrink that guy down and that like so. Now I have two planes that slice right through the center of my pipes, of my tubes. If I come in here and say mid-plane, I can go here, and now it's creating a plane right through the center. Okay? Now, I'm going to back up to show you a couple other options that would have worked here. I could also have done tangent plane on this face, and you'll notice it creates a face tangent, or a plane tangent to that. I'll do that again, tangent to that, and I have two planes that I could now do a mid-plane, right? So from there to there, and I now have a mid-plane. Obviously that's much faster, but I wanted to kind of show the whole axis through the center and being able to rotate those planes very specifically. Okay, and then the last way, which I think is the cheater way, is if I turn these guys back on, I know these are symmetric, so I could come in here and say mid-plane, and I could say, for example, between that face there and that face there, and it's going to create a plane right through the middle. That, you know, works, but I would be a little leery about that, you know, if this ever changed or something like that. But I mean, that's the fastest way of doing it. But I like the axis through the center, where we created those guys, and then we created the planes at an angle, and then we were able to do the mid-plane. In fact, if I come in here, I could turn off the planes that I really don't need. I just want the one in the middle now. I could even turn off the axes. And let's create a sketch. Create a sketch. I want to, you'll notice the origin is in the correct spot. I'm going to pretend that that didn't happen. Maybe it's not exactly in the center. We don't want to assume that. So I'm going to project. P for project. I'm going to project one of these tubes. Now I want to do the whole tube. So I'm going to say body. I'm going to click on that tube, and say OK. And we just projected the geometry onto this plane. Now, let's say it wasn't perfectly centered. How could I get the exact center? Well, I could come in here and draw just a couple construction lines from one corner to the other and from one corner to the other. And then where they cross, and in this case it's perfect, but where they cross, that is my center point. Okay, so that's one method of doing that. So I'll go ahead and create my circle at the center, and according to the drawing, the pipe is, how big is it? 25.4, I should remember that, 25.4. I'll say OK and finish my sketch. Let's turn these tubes back on. So we now have a plane that's perfectly centered between the two pipes. Our circle is centered perfectly the length of the pipe. Okay, I'll go ahead and do my extrude command again. And I'll just start to drag to kind of give it a direction. So here's a neat thing. I don't know exactly how far I need it to go, but I want it to go to this pipe. So I'm going to say to object, and I'll click on that pipe, and you can see it. Sure enough, it's extruding to that pipe, and it's creating that special little curve for me. Well, I also want it to go this direction. So instead of one side, I'm going to say two sides. I'll start to drag this direction. I can see that that's right here. And again, instead of a distance, I'm going to say to object, click on that guy, and it's going to extrude that distance to that object. And then lastly, I want it to be hollow, so we'll use the new thin extrude. Notice my extrude menu is getting much longer here, but I can now specify what the wall thickness is. In this case, I think it is 1.5, and it's going to hollow that out for me, all in one command. So if I turn off one of these tubes, we can see that sure enough, that's hollow. And it's the correct length. We didn't have to say it's 70 millimeters or anything like that. It's exactly where it needs to be. And this will be welded in place when we get to the drawings. Let's turn on our end cap assembly. Okay, so we are pretty much done. Now let's take this to the next level. This is where it gets kind of fun. I'm going to activate this end cap. That was that little metal piece that we worked on originally. Okay, let's go all the way back in time. Let's edit this sketch. Let's throw a dimension on here. And then instead of 185, let's make that 300. So you'll notice that that got larger. I'm going to say finish sketch. And look what happened. Everything updated accordingly. And this is really the power of parametric modeling. So the plastic cover updated, the screws moved to their correct location, the center pipe is the correct length, this pipe is the correct distance where it needs to be. This is kind of honestly the power of parametric modeling. If you kind of think, how is this going to work? Everything updates. And that's kind of why I did the, where we created that one part and then we did the cover and then we punched the holes through both and then we punched the square hole through it, because that's where the arm extension is going to slide in and out through that pipe and stuff like that. But it's so cool that you can, down the road, make a change and everything updates accordingly. So with that, I want to thank everybody for attending. I'm going to check my questions real quick. I don't see any other questions that came in, so hopefully everything made sense. Tune in next week. I think Angelo is going to continue on with his CAM series, the intro to CAM series, and then we'll continue on with this table. In fact, I'll show you where we're headed next. We're going to work on the sheet metal part here. You'll notice like the legs, rotate into place and all that kind of stuff. We'll do the handle, we'll do the extension arm. So this will be a multi-part series, but hopefully you're learning some new tips and tricks. So with that, have a wonderful day and keep fusioning. Thank you.